Well, hey guys, thanks for visiting the Next Level Carpentry channel here on YouTube, where I'm going to show you how to make the great Christmas star decorations you saw in the video thumbnail you just clicked on. The overall design of these star decorations came from a photo on Pinterest that I found while browsing for Christmas decoration ideas. I liked the general design of the 5-pointed star and thought I could use a Next Level Carpentry design upgrade, which I'll get by using two-tone wood for contrast in the perimeter of the design like you saw in the thumbnail. And I'll get that contrast by using various species of wood, and these are just scraps from projects mostly on my day job. This curly maple is from some trim I made. There's a piece of ash from a Next Level Carpentry sawhorse, along with the cherry and walnut, and underneath there's some white oak. And this is a great project for using up scraps like this because the parts aren't really that big, and a relatively small scrap goes a long way. And because all I have is a concept of what this star looks like, I don't really know how I'm going to make it, so we'll go on this journey together. But I plan on using a modified crosscut sled to make the parts for the stars. That's what this plywood and these two strips are for. But before I start all of that, I want to go through the geometry of the star itself, because that's a big part of this project, understanding the geometry for the angles, for the parts of the stars, and then the joinery for making the stars come together. And to work that out, I'm going to do a full-scale geometric drawing on this piece of white melamine for sizing the parts and positioning the lap joints, etc. Now I can do all this geometry in SketchUp, which is a great way to do it, but not everybody has SketchUp. Plus, having a full-scale actual drawing really helps to determine dimensions, etc. on those pieces. So I'll swing the camera around for an overhead shot on this piece as I channel my inner student and try to remember the days back in high school geometry class when I learned how to do this stuff in the first place. So let's get this show on the road. All right then, because we're working with a 5-point star design, I'll start out by drawing a pentagon, and the pentagon will have a diameter of 9 inches. In other words, it would fit inside a circle 9 inches in diameter. So I'll start out by drawing a center line with enough room around it for that circle. I'll just do that with a framing square here. And then I'll draw a center line for the circle, just an arbitrary 6 inches up here, like that. So this will basically be the center of the star, the pentagon, and the circle. And I've got the lighting about as good as I can so that this shows up. But to draw that 9-inch circle, I'll make a radius of 4.5 inches, which is going to be right here, using this rule. And now I'll use a compass to draw that circle. And accuracy is very, very important on something like this. Just going to expand this out here and draw that circle. And I repositioned the light and the camera so you can see a little better what's going on here. And recall, I'm going to draw a pentagon, and the primary angles of a pentagon are 72 degrees. 72 times 5 is 360, makes up the circle. And the points of the star will all touch the circle with a 9-inch diameter, 4.5-inch radius. And because the star points are going to be mitered, I'm dividing the 72 in half, so I'll be working with 36-degree angles on each of the piece. That'll get built into the sled that cuts the parts. And to get a starting point for laying out the 5 points of the star, I'm going to subtract 72 degrees from 90 degrees, which gives me 18 degrees. And I set that up on this stare-at protractor square, and I'm just going to guesstimate a point right about here for the first 72-degree point. You can rewatch the video if that doesn't make sense, but I'm going to take this dividers here and lay out that distance on the divider and see how close we get. I'm just going to go right to that pencil mark and then carefully step off that distance 5 times around the circumference of the circle. 3, 4, 5. And I'm coming up just a little bit short, so I'll divide that by 5, give a little twist, and go around the circle again. We'll go this way this time. 1, 2, 3, 4, 5. One more time. It's important to get this accurate, so I'm not measuring 2, 3, oops, 2, 3, 4, 5. And I'm going to call that right on. So I'm going to dig these points in a little bit. 1, 2, 3, I keep getting that mixed up. 3, 4, and 5. And that way, even if my angle is off, I can verify it by dividing up that circumference with the dividers into 5 exactly equal segments. So here's one of them. And I can just use a rule for the others. So I have 5 points of the pentagon. 1, 2, 3, 4, 5. And I can use a little lacquer thinner on a paper towel to erase unwanted lines to keep this drawing from being confusing. And that should do that. And it goes without saying that the 5 points around the perimeter of the circle will be the points of the stars, and those lines also represent the cuts between the pieces of wood that make up the points of the stars. And for this project, I'm going to make the segments of the star 3/4 of an inch wide. So I've just got a stick of wood here that's perfectly straight and exactly 3/4 of an inch wide, and I can just lay it on these points here and draw lines that'll represent the 5 pieces that make up the 5-point star. And that is as simple as that. And at this stage, I take a minute to clean up the drawing by erasing excess construction lines that distract from the overall purpose of the design, which is to see how the 5 pieces fit together to make the star. And then I erase one set of lines on each piece that represent the way the pieces look when the lap joints are cut, which gives the star the cool interwoven look that it'll have when it's complete. And what this represents in the final star is that this piece gets dadoed on the back and that piece gets dadoed on the front for a half lap joint at each one of these 5 intersections. And that little design feature is what drew me to this overall design in the first place. And now, to finish up this full-scale drawing, I used a triangular square that just happens to be 5/8 of an inch wide to draw lines that represent the 1/8 inch strip of contrasting wood that'll form a perimeter around the star and a little extra interest to the star design overall. And although I'm not really sure how proud my high school geometry teacher or drafting teacher would be of me for creating this drawing, the main takeaway at this point of the video is that I can measure the overall length of each of the individual star segments at 8 9/16 of an inch. So you can see how the drawing helps me get the proportions of the stars right and also determine the length of the pieces I need to make the stars. So if I were making plain stars, I just need to make wood that's 3/4 of an inch wide and long enough to get at least one segment of star at 8 9/16 inches long. Now the stars in the concept picture, I'm pretty sure those pieces were 3/4 of an inch square, but I've decided to go with a 1/2 inch thick for the stars to make them a little more refined looking. And if I were just making plain stars, that's all I would need to do is make blanks that are exactly 3/4 of an inch wide and exactly 1/2 inch thick out of wood, which is what I've done here because I'll make a couple stars out of just a single color wood and I can use these for testing the fixture to cut the pieces. But because we're going with a next level look to these and having a thin accent stripe of contrasting wood, I need to make blanks of the same size, but have that strip of contrasting wood incorporated in it. And I could just mill up strips a 1/2 inch by 5/8 and then other strips that are an 1/8 inch by 1/2 inch and glue them together. But I'm going to show you a pro tip that I'll use to create a whole stack of blanks with the contrasting wood in them. And I'm going to make it out of this pile of scrap here, which you saw earlier, but rather than cut up all those tiny individual pieces, I'll make a blank like this to simplify the process. And let me show you up close what that pro tip looks like. So here's one of the solid wood blanks that I'll use to make up a star. It's 3/4 of an inch wide and a 1/2 inch thick. But on the next level upgraded stars, I want to have a strip of accent wood on here, just an 1/8 of an inch wide, so that the blank will have a wide piece of solid wood and a little accent stripe along the edge. But I don't want to make pieces that are a 1/2 by 5/8 and then glue a piece that's an 1/8 by a 1/2 to it, because that's too tedious and prone to error. So the pro tip I use to achieve this result with a lot more accuracy and a lot less fuss is to make up a blank like this. And what I've got here are two side pieces that are exactly 5/8 of an inch square, and then a piece in the middle that's about a 1/2 inch wide and about 5/8 of an inch tall. And what I accomplish with this is I'm gluing these bigger pieces together. This is a lot easier to clamp and glue, and it's not so critical if everything doesn't line up. You can probably see the irregularity here in this dummy blank that I slapped together for this part of the video. But the mainest thing here is that these pieces are exactly 5/8 of an inch square, so I can glue them on in either orientation. And they need to be straight and smooth so that I get good glue joints. And the piece in the middle, I'll make them exactly a 1/2 inch, but they don't really need to be that wide. They can be a little wider or a little narrower, and it doesn't matter. But circling back, these pieces need to be 5/8 of an inch wide because that's their final dimension. And I make this piece extra wide in the middle so that I can rip from here 3/4 of an inch this way, like that, and then flipping it over, I can rip this 3/4 of an inch from that side. And I'll actually rip it about 11/16, but this will just end up as waste for the saw blade and then one pass through the thickness planer, which you'll see. So that's how I get the blanks that are 5/8 of an inch plus 1/8 of an inch for 3/4 of an inch width. And by gluing this up ahead of time with extra thickness here, once I've glued the blocks together, I'll plane one face so it's perfectly smooth. Then I'll flip it over and plane this face down until the blanks are exactly a 1/2 an inch thick. And the whole time this will be glued up in this little Oreo cookie looking sandwich here. So that once I've got this piece to exactly a 1/2 inch thick with 5/8 of an inch sides, I can rip these off, then run these blanks with the accent strip up, and one pass through the thickness planer will smooth that up. And that way I'll just end up with those blanks that are 3/4 of an inch wide, 5/8 of that width being one color wood and another 1/8 of an inch being the other color wood, and they'll be planed down to a 1/2 inch thick. And if that doesn't make sense now, it will as the video progresses. And if it isn't obvious by now, that right there is exactly why I don't do TikTok videos or many YouTube shorts, because I feel that tips like this are key to success on a project like this that require both quality and quantity for success. So with that in mind, I'll be making some strips that are 5/8 by about a 1/2, and then another pile of strips that are exactly 5/8 of an inch square, and then I can mix and match the contrasting colors to produce an attractive variety of these Christmas star decorations. And I'm just going to breeze through this milling process here in the video because I've done a deep dive on this in plenty other Next Level Carpentry videos. And the process here is the same as you see in any of those videos, where I start by flattening one face and straightening one edge of each piece of scrap on the joiner to remove all cup, twist, and bow to make them flat and straight for the rest of the milling process. Once all the pieces are flat and true, I put them flat face down on the table saw and rip the opposite edge parallel and straight to the first edge. Next, I go to the thickness planer, place the flat face down on the platen, and take enough passes off the top face to remove all squiggle marks on them so I know both faces are flat, smooth, and without twist. Then I go back to the table saw and rip oversized strips for the sides and centers of contrasting wood that will make up the laminated star segment blanks. Now I use a Sharpie marker and draw a short line on one end of each strip that helps me keep all the pieces organized and make sure all four faces of each piece gets cleaned up by more passes through the thickness planer. Back at the thickness planer, I orient all the strips and plane each face at least one time to make sure all the pieces are the exact right dimensions at either 5/8 of an inch square or 5/8 of an inch by 1/2 an inch for proper sizing for main or contrasting color strips for Next Level accent strip blanks for these Christmas star decorations. And after about a 1-hour mini milling marathon, I come up with enough parts to make a whole bunch of these star component sandwiches. Each piece on the outside is exactly 5/8 of an inch square, and all the contrasting color strips in the middle are exactly 1/2 by 5/8. And there's actually twice as many star segments here as it appears, because each one of these sandwiches produces two of the pieces I want to end up with the dark wood and a narrow light wood strip on it. So each sandwich like this makes 6 star parts. And in this case, where the contrasting wood is cherry, this will make 6 parts. I only need 5, but I'll be able to make 1 star with walnut and a cherry accent strip on it. And the main takeaway here is the milling process to get to this point, because each of these pieces is 5/8 of an inch square on both sides, so I can turn them either way. I mentioned that before. And then the piece in the middle is the same thickness, but because these pieces are 5/8 of an inch thick, a full 1/8 of an inch thicker than the end result, when I glue them up, everything doesn't have to be really flush, because as you'll see, I'll flush up one face on the joiner, run them through the thickness planer before ripping them down and doing a final planing pass. So regardless of the exact process you use to get to this stage, as long as your pieces are milled accurately, you're ready for glue up like I am. So I'm going to get this staged and show you what that looks like. So here's my setup for glue up. I've got the bench covered with a piece of cardboard for glue drips. Then I suspend the parts above the cardboard with these strips, and these are just corners cut off a block of wood to make these little 45-degree pyramids, so that the pieces are just sitting on this little point of that. It keeps the glue from smearing around so much. And because I did my homework in the previous steps, all these pieces are nicely sized, nice clean planed edges there, so the glue joints will be nice and tight. And the main pro tip here is that I'll get 6 star segments out of each one of these glue up assemblies, even though I've just got 3 larger pieces to glue up. I'm going to use Titebond 2 glue for this. It's plenty good, and it's light colored. If I use Titebond 3, it's kind of dark, and it might show up in some of these joints. Even those things are going to be super tight. But to glue up one of these stacks, I just flip a piece and flip a piece like that. And then I flip the pieces to glue them together like that. Just do a little bit of pressing here. Should see glue squeezing out the top, which is a good thing. And the surfaces are nice and gluey on the inside there. I'll add just a little bit more right here. Probably not necessary in the final picture because the clamps will make that glue squeeze out, but let's get that glue distributed in there and give it an initial squish. And carry on to do that with the other 2 blanks I'm gluing up in this session. And the cool part is it's just that quick and easy to apply glue to these 3 sandwiches, which will make up a total of a dozen star segments when they're done. Once all the glue is applied, I can just put some clamps on there. And I want to use clamps with pads, like these clear ones here I got from EVS, so that I don't mar the edges of these pieces right here and there. If I was worried about it, I could put a protector strip on there. And because I've got extra thickness on these, I don't really need to make sure everything is perfectly flush top and bottom. I'll just get it nice and close with those clamps. And I don't want the whole thing to taco shell on me, so I'm going to put 1 clamp on either face. Alternate the clamps like this. And I can do a little adjustment here as I go, just to get it close. But I've got an entire 1/8 of an inch to work with here, so there's not a lot of stress about making sure that's lined up perfectly. And some of these pieces kind of warped as I cut them into thin strips, but they seem to plane out okay. Everything's okay with that. And I'm going to go ahead and add 3 more clamps to this, just because I can, and I want nice tight joints on these stars. Another thing I could do would be put a wider strip on either side to distribute that clamp pressure a little more evenly, but I'm just going to do this because it's really overkill already. And more pressure is better on a glue up like this with 2, 4, 6 glue joints being squeezed at the same time. And now with those clamps applied, I can take a few minutes to clean up the excess glue squeeze out. And in my thinking, glue squeeze out's a good thing because I know I've got a good full joint there. And anyone who's ever seen a Next Level Carpentry video before knows that I do not use wet rags for cleaning up glue squeeze out. I just reach for a bucket of sawdust to soak up that extra glue, but as it's appropriate for the season and the project, this time I'm going to use Stardust for cleaning up the excess glue. But I just take a handful of that fine Stardust, sprinkle it on here on the wood wing. brush it around to soak up the excess, flip it over to dump off the loose sawdust, and then use a sharp putty knife to scrape away the soft glue that's partially soaked up with stardust. And here again, I don't need to do a marvelous job because I've got plenty of thickness so I can plane away any of the glue and unevenness before I proceed to the next step. But I do want to get the big chunks off there because that can throw off the results. And I just flip the piece over, then lather, rinse, repeat to clean up glue squeeze out on the other face of the blanks next. And that's going to be plenty good for this batch of blanks. And I'll just leave them in the clamps for a couple hours until the glue is good and dry. After revisiting geometry and drafting classes earlier, I'll revisit my math class now and tell you that you're looking at enough blanks here to make a dozen of these Christmas star decorations. Because if I do my math right, there's enough material here to make 62 individual star pieces for those 12 stars and a couple of spares. And I consider that a worthwhile batch to make. And you'll notice that I glued this one up in the video because I wouldn't dare glue up this big with the video camera rolling because that is strictly a recipe for disaster. But with everything said and done here, I can just pull the clamps on these guys. And if I did everything right, I end up with blanks for stars instead of very pretty but rather thin cutting boards. And I hope the takeaway at this point is how easy it is, relatively easy it is, that is, to glue up so many pieces so quickly and accurately. So I'll get this unclamped the rest of the way so I can take the next step in producing those star parts. Is it a cutting board or is it star parts? I guess it's star parts. Before I advance to the next step, which is running these pieces over the joiner, I want to scrape any nubbins of glue that are left on there after the stardust cleanup process. So I'm just using a carbide scraper, which can make some nasty noises, but does a really good job of scraping off any little globs of glue left behind that could disrupt the flattening process on the joiner. And I go primarily by sound and feel with the scraping process, where the most important part is just to make sure there's nothing on there that make these pieces rock after they're scraped clean. Because a little glob of glue on one corner of this could make the piece rock as if it were twisted, and that would create problems that could result in the edges of the pieces being twisted, and that would be a mess going forward. But as it is, these blanks are good to go for the next step. And this flattening step really is just as easy as it looks. I added some squiggle marks for clarity, and I've set the depth of cut to a skinny 1/16 of an inch, and take a light but slow and steady pass off one face of the blanks so they're flat and smooth. And I know they're flat and smooth when all the squiggle marks are planed away. And even after 2 light passes, I've still got plenty of thickness to smooth up the other side of the blanks as I plane them down to that final 1/2 inch thickness. To dial in the right thickness on the planer, I run a short strip, planed side down, through the planer and adjust the depth of cut to take a light pass from the top uneven surface. Once I'm satisfied with the setting, I run all the blanks through for an initial cleanup pass. A pro tip here is to run pieces through tightly end to end, which reduces snipe on all but the leading end of the first piece and the trailing end of the last piece. After one pass on all the pieces, I lower the cutter head to exactly 1/2 inch and run them all through again. I had trouble with one piece at the end because I took a little too much off while flattening it on the joiner, so I lowered the cutter head a skosh for a final pass to clean it up 100%. And now at this point, if you're following along and paying close attention, all the blanks should be identical in thickness and width. The 2 edges are 5/8 of an inch wide, and the whole blank is 1/2 inch thick. I had some difficulty with one of the blanks there at the thickness planer. This one is a 1/64 of an inch thinner than the rest of them, which is okay. I just marked this and I'll make sure that this makes up 1 star. But once you're at this stage, everything's set up for the final fabrication stages, which is to separate these blanks into 2 individual pieces, which I'll do on the table saw. And this is the step where I want to rip the blanks down into 2 strips that are just a little bit under 13/16 of an inch, which you can see here if I use a double square. That way I'll have a little less than 1/16 of an inch to plane away to remove saw blade marks from this step. So I just raise up the blade, so the teeth are about 1/8 of an inch above the workpiece, and set the fence to that skinny 13/16 of an inch. And proceed to make 2 cuts on each blank to separate the 2 star beams. And I hope you enjoy that little Christmas jingle as I rip these strips down, so that now they're a strong 3/4 of an inch wide, and I can run them through the thickness planer with the accent strip up to plane them down to that final width dimension of 3/4 of an inch. And because this is curly maple, I'm going to run the thickness planer on the slow speed to prevent tear out, which would kind of spoil the whole purpose of putting that fancy curly maple edge on these in the first place. And here we are back at the thickness planer, which in this case is serving as a widthness planer. And I've got the height setting to just a touch over 3/4 of an inch, so I can clean up these edges in 2 passes, because a delicate cut is less likely to chip out than a heavy full pass cut. And I feed them through the planer in groups of 6 with the leading edge staggered, which goes a long way to minimize snipe when planing pieces like this. The process takes a little longer because I've got this set on the slow feed rate, again, to minimize chipping, but it doesn't take long to run everything through twice to get the blanks down to their final finished width of exactly 3/4 of an inch. And from what I hear, this is about the point in the Next Level Carpentry video where a TikTok video would start, where somebody would walk in and say, hey, let's make some Christmas decoration stars out of these pieces of wood. But we've been off in the weeds to get to this point where I've got all the laminated strips down to their final size of 3/4 of an inch wide, exactly 1/2 an inch thick. And so that all these laminated strips now match up with some solid wood strips that I made earlier at the same width and thickness. So that at long last, I'm finally ready to move into the next phase of this video, which is to make a next level crosscut sled that doubles as a fixture for cutting the sharp angles and short dados on about 100 parts for about 20 completed stars from all these milled up star beams. So go grab another coffee or beverage of your choice, and I'll wade off deep into the weeds again and show you how to make a next level crosscut sled with dedicated features for cutting star parts. With all the blanks for making the stars completed, it's time to get into the business of building a fixture. And I'll start that with a reminder that the purpose of this fixture is to fabricate parts for the stars. And to fabricate those parts, there's going to be 2 operations. The first is to cut the long, sharp miters on each end of these star pieces. And the other function is to have a consistent, repeatable, and reliable process for cutting half-lap dados on each of those pieces, one on the back side and one on the front side. And I'll be using the same fixture, but with 2 different setups for those 2 operations. And because I want to cut the parts to length before I set up and do the dados, I'll start with that process first. And back to a scale drawing here, the points of the stars have an included angle of 36 degrees, so the miters where those 2 pieces meet are going to be 18 degrees. And if you recall, the pieces are going to end up at 8 9/16 long. So I've got a piece of plywood here that's big enough to put those parts on and use clamps and whatnot to make the whole thing work. So the first step in making this fixture or modified next level crosscut sled is to get it set up with runners that fit in the miter slots on this table saw. And the way I go about that is to start with this piece of plywood I showed you before, and the exact size isn't all that important as long as it's big enough, but more importantly, it needs to have parallel edges and the corners need to be very square. And then I've got a couple of strips here that I made up ahead of time. They fit in the miter guide slots. It's just a nice fit. They can slide freely, but there's no wiggle in those. And I want these strips to be thin enough so that when they're actually put down in the table saw top, that they're below the surface of this top, so that when the fixture is in operation, these aren't running on the bottom of those miter slots. So with those pieces lined up, I'm going to attach these runners to the plywood. And I'm going to show you a foolproof way to get this done for this or any modified crosscut jig fixture. Like I said a minute ago, these pieces are best when they're thin enough that they ride below the surface of the table saw. But I want to glue them onto the underside of that piece of plywood. So I'm just going to take a couple of little thin strips here. And now when I lay these pieces in here, the top of the wood is actually above the table saw surface. And I'm lining these two ends up with the back edge of the table saw table. And I want to glue this piece on here so that the blade basically cuts through the middle of the piece, and the action of the fixture will square up the cut. But for convenience and to make layout easier, I've positioned the rip fence so that it holds the center of the piece right over the center of the blade, and that when I use the fixture, the blade doesn't cut all the way through the piece front to back, it'll stop about here. So I want to glue this piece to those strips in this position. So I can mark these strips right about here, kind of as a visual guide. And now I'll use Amazing Starbond products, medium thick flexible CA and accelerator to get this done in a simple foolproof process. And I do that by spraying accelerator along these two lines that I've lined up with those strips. Give it a nice dose of the accelerator right there. Then I'll take the medium thick CA and put some blobs of it along here, like so. And if you're familiar with CA, you understand that there's not necessarily a tight working time between applying the accelerator and applying the CA glue. But once the glue is applied, and I take the accelerated piece and drop it on there, like that, I want to hold this down for a good 10, 15, 20 seconds, just to make sure that that accelerator sets the CA glue and that the two pieces are stuck together. And if you know anything about CA glue, you know when you try to show off and show how fast it works and how strong it is, sometimes it fails. But I think we should be in good shape here. Yep. So now those pieces are stuck on there firmly, and was pushing kind of hard because some of the CA glue puddled out and got on these rails. But this is exactly what I want. Two rails held perfectly in place, parallel to the edges, parallel to the fence, and parallel to each other in the miter guide tracks on the table saw top. And even though these are firmly attached now, the CA glue is good and reliable, I want to back it up with a couple screws so that none of this fails if this jig gets banged around during use. So I'm taking one of my favorite things, which is a snappy bit here. I'll just drill a couple countersunk pilot holes in each of the strips and drive screws to supplement the CA glue and make sure these rails stay put in use. And with this setup, I'm using number 7 by 3/4 inch long flathead screws to attach the runner strips to the fixture's face plywood. And it's important that the screw heads don't protrude out of the bottom of those runner strips because they could catch in the bottom of the miter guide slots and make the jig hard to push. But now I'll take a sharpened putty knife and clean up the strips and the little excess CA glue that puddled out so that it doesn't interfere with smooth operation of the fixture in use. And the last thing I'll do here before flipping the fixture over is to apply a generous coat of Johnson's paste wax, which is really rare stuff these days, to the bottom of the fixture and on the runners so it slides smoothly in use. And FYI, the best way I've found to apply a generous coat of paste wax like this is to take an old shop cloth and put about a golf ball shaped dollop of paste wax right in the middle of the rag, and then twist the rag tightly around that dollop of wax, and then apply the wax by pushing hard on the rag, which squeezes the wax out through the pores in the cloth for a nice, thick but even coat of wax on raw wood. And I finish up with a quick wipe using a blue shop towel to remove excess wax and to really slick up the fixture. And now, while I'm at it and thinking about it, I add a disposable but sturdy handle to the fixture to make it safer and more user-friendly to use. Just like that. And now, with the fixture all set up, I can remove the fence and stow it out of the way because the function and accuracy of the fixture is all built into the fixture, which makes it a wonderful thing. And now it's time to do 2 more things to this fixture before setting up for the first cut. Thing 1 is to add a stop block at the outfeed side of the table saw table. And I highly recommend a piece of kiln-dried white oak, approximately 15/16 of an inch thick and 19 14/52 of an inch long. This piece acts as a stop for the runners on the fixture so that you don't overcut the fixture in use. And if you don't happen to have oak like that in your inventory, you could just use the handle off a broken hockey stick. But regardless of what you use for the block, clamp it firmly in place so it doesn't shift during use. Thing 2 is to make a clearance cut in the fixture. So I retract the fixture and raise the blade till it's about 1.25 inches out of the table, which is high enough to cut through the fixture and a 1/2 inch piece of material on top of it, and then fire up the saw and advance the fixture into the spinning blade until it hits the stop to complete the clearance cut. And now if I retract the blade, that clearance cut shows me exactly where the cut will be made on the workpiece when I get that set up in the next step. As I said earlier in the video, I'm just making this whole thing up on the fly, and I spent some time brainstorming this, burning up brain cells so you don't have to, but I've come up with a plan and a design for the setup I'll use to make those 18-degree cuts on the star pieces. And let me show you what that looks like up close. I used one of my full-size layout drawings to double check this setup for the 18-degree bevel set up on this protractor square, so I can use it here to draw a layout line for cutting these pieces. I want to make sure that the piece is cut all the way through by the time it gets to the end of that slot, so I'll draw a layout line to make that happen, which looks about like this. And what I want to do is attach a fence along that line so that it holds the piece in exactly that position as I run it past a spinning saw blade to make the cut. And I'm using a piece of 3/4 inch Russian birch here. It's about 1.25 inches wide. And I drilled a clearance hole through that piece. And I'll line it up back here, about like that. Drill a little pilot hole in here. And drive a screw to hold it in place. And that'll hold the fence securely in position for as long as I need it to. And in a perfect world, I would just drill another hole and put another screw in this end. But because this miter has to be dialed in so accurately, I may need to do a little bit of adjustment on this fence back and forth until I get that cut dialed in so the star points come out to exactly 36 degrees when they're glued together. So I want to make this end of the fence so it's adjustable and I can swing it back and forth a few degrees with the ability to hold it in that position while I make the balance of the cuts. And there's going to be nearly 200 of them before this project is done. And if this wasn't Next Level Carpentry, I'd just cut a slot in here, put a screw in it, move it back and forth and tighten it up. But because it is Next Level Carpentry, I want to show you a fun little feature I dreamed up to get this done much more elegantly and with a super high degree of accuracy. And the first step for this little design upgrade is to remove the fence from the fixture and take it over to the drill press, where I'll drill a hole through the center line at the other end of the fence with a 7/8 inch Forstner bit, for reasons you're about to see. The exact location of this 7/8 inch hole isn't all that critical, but I do want it pretty near the center line and fairly close to the opposite end of the fence for optimal function of the feature. Next, I cut a length of 7/8 inch dowel with a snug fit in that hole I just drilled and about 1.5 inches long, and slip the fence into the vise and the dowel into the hole. Then I take a nifty round stock center finder that I designed and made on my X-Tool P2 laser and use it to draw 2 center lines on the end of that 7/8 of an inch dowel, with crisp, sharp lines drawn with a Papermate SharpWriter pencil. And if anyone's interested, I'll add plans for this center finder on the spring page listed on my RecLeague site in the video description. Now I take my contraption back to the drill press for another simple drilling operation. This time at the drill press, I've chucked up a 3/16 inch brad point bit, and I'll drill a hole along one of these center lines, just slightly off the center point of the dowel. Just like that. Next, it's back over to the fixture on the table saw, where I redrive the screw that holds the fence to the fixture. Then, with the fence snug to the table, I roughly align the fence with the 18-degree pencil mark from before, and rotate the dowel so that the center line with the 3/16 hole in it is roughly lined up to the center line of the fence. After that, I use a small pilot bit to drill down through the hole in the dowel and finish up by driving a number 10 by 2 inch Phillips panhead screw down through the dowel into the fixture underneath. And you can see how that dowel holds the fence firmly in place, which in turn will hold the star part firmly in place at the angle set. But the beauty of this Next Level apparatus here is that I can loosen the screw and rotate the dowel, which acts as a cam because the hole is off center. And using this slick setup, I can easily micro adjust the angle of the fence to dial in the cuts on the star beams. And that offset between the center of the dowel and the center of the screw provides plenty of range for dialing in the angle on the star parts. And I'll make an initial cut with it set just like this. No fixture, no matter how elegant or accurate, is complete if it's not safe. And with the nature of these long miters, the saw blade's really going to want to pull this piece into the blade, could result in a kickback, inaccurate cuts, etc., etc. And because of the steep angle of the cut, I would have to put my fingers way too close to that blade for comfort if I was to hold the piece in position with my pinkies. So to address all that, I'm going to incorporate a Dado style clamp as an additional measure for safety, accuracy, and consistency. And I really love this style of clamp. There's plenty of power here, plenty of pressure, but they're adjustable and versatile so they can be adapted to all sorts of things. I use this style clamp just because it'll be handy to use repetitively for cutting all these parts. And to increase the range of thickness that this can clamp down, I added a piece of 1/2-inch plywood there by just screwing the clamp to the block. And I adjusted this little push button here so that it's about in the center of the piece. And I'll slide it down this way so it's real close to the cut here. That should work good. Actually, I want to move it up this way. So I think that'll be a good position. And I can just screw this block into place here to make everything work. And to do that, I'm using another snappy bit to pilot and countersink holes in the block, and then using some 1-inch Torx drive screws to attach the block to the sled. And those screws are a little bit long, so I'm going to use a little die grinder to knock the tips off them so the fixture slides easily without scratching the machine finish on my table saw. And even though a pneumatic die grinder is painfully loud, I put up with the noise for how fast it grinds away the sharp tips of those screws for a fully functional fixture. And how's about them apples? And I'm fully aware that a deep dive into fixture building like this really burns up time in a video, but this is really what it looks like designing and building a one-off fixture pretty much in real time. And I hope you understand why it really doesn't make sense to sell plans for something like this, because the materials available, the setup, the type of material, the end product being made, all that stuff is so variable. There'd have to be 1,000 sets of plans to even come close to covering all the applications. But again, I do feel it's important to include all this detail so viewers can extrapolate and adopt some of the ideas and thoughts here, whether you're building a jig for making these star decorations or something entirely different. This should give you a real good idea of what the process looks like. But with all this set up, I do believe we're ready to take this baby for a test ride. What do you say? And according to the owner's manual, I need to remove this setup piece here and crank the blade up so it's high enough to cut through the piece like that. Do a test here. Yep, it's going to cut into this. And I'm going to want to cut into that fence a little bit before I make an actual cut. So let me do that right here and now. That should do that. Now I'll just clamp this piece back in. I'm just going to cut a minimum off the end here. Hold it against the fence and then clamp it down firmly. And fire up the unisaw once again and see what we get. How sweet is that? Look at that baby. That is one sweet cut, wouldn't you say? And I'm so pleased with the way that works out, I think I'm going to take it for another spin around the block. Just like that, like nobody's business. 2 cuts complete and ready for a test fit of the angle setting. And as you might expect, I'll use the full-scale drawing that we did at the beginning of the video to check the accuracy of these miter cuts. And I've clamped a stainless steel straight edge down to the drawing, making sure that the edge of the straight edge is exactly along the line that I drew, and I can actually see the little pinholes where I use the dividers to lay out those marks. And for the pieces, I'm just going to temporarily hold them together with some tape. And I'm using my favorite green frog tape that I switched to when 3M quit making good masking tape. I can just put a little stick of it around here like this and place those 2 points together, making sure the long point lines up. And I can tell you what, those are sharp long points there. Then I just pull this tape with a bit of stretch across that miter, stick it down, wrap that around, and that's about what I'll do when I glue up these joints at the end. But with all that set up, I can just slide this assembly along the straight edge that's along that line laid out at the beginning of the video, and just keep an eye on this side to see how it lines up with everything. And I don't think I can get it more accurate than that. There's the slightest amount of play in there, but that's because we're working with wood and not tool steel. And it would be easier to clamp these long points together to close a gap here than it would be to make an adjustment if the gap was on the inside of the miter. So I am going to go with that. Woohoo! And now with the fixture all set up, dialed in and approved, I'm going to put it into production mode and make angle cuts on a number of the solid blank pieces so I have something to work with when I make the next setup, which will be to cut these to identical length with that sharp 18-degree cut on both ends of each piece. Changing the setup to cut these pieces to length is pretty straightforward. I basically need to flip the pieces end for end and use a stop block to set them to the right length and then make that second cut. So let me bring the camera overhead and show you what that looks like before I throw another wrinkle into this setup. And you'll remember from earlier that these pieces are going to be 8 9/16 long from the sharp point on one end to the sharp point on the other end. So I'm just going to put this piece here and use a rule to put a mark on the piece exactly 8 9/16 away from the sharp point on this end. So that's the length I need, and the angle will go this way. And on the fixture, I put a mark at the exact point where the blade meets the fence, which is right here. Just put a pencil mark there onto the top of the fence. So I can line up the pencil mark here with that line, like that. Hold everything in place and clamp it down so that when I make the cut, the long point ends up precisely there. And because I want to set this fixture up to make 100 or so of these pieces, I want to set up a stop block here. And because the point of these pieces is so sharp, I don't want to just bump those pieces into a block. It just wouldn't be very accurate. So I took another piece of this fence material and I created this little stop block that'll fit just like this. And when this is attached in place, I can just slide a piece with the long point right into there and clamp it down. Every piece will be the same. And this is what it looks like from directly overhead. The piece will just slide into that little point there, and I can lock it in place. And that'll be very simple and repetitive as long as no sawdust builds up in that little crevice there. But I want to be able to cut pieces that are too long to fit with that stop block in place. Because I don't want to make one cut on the end of each piece, I want to be able to make cuts on each end and then cut pieces off of each end and then start over. That'll kind of make sense as I'm going along. But the bottom line is, to cut some pieces to length, I want to remove the stop block so that I can make the first cut on some of the long pieces. So to do that, once this stop block is in place, I'll need to remove this stop block. So I'm going to add a second stop block for the first stop block, like that. And this one will be permanently attached to the fixture. So I can use the fixture either to cut a second point on a short strip or cut the first point on a long strip. And I'm fully aware that I could just cut a bunch of these pieces to about 9 inches long, cut a sharp end on all of them, and then add the stop block and cut the other end on all the pieces. But there's two reasons I'm not doing it that way. One is because I have the luxury of doing it that way with this setup. If you're making a fixture and you don't have that luxury or that option, I just wanted to show you a workaround that I could build into this fixture. And the other reason is that I need to cut some of these parts and test the dado part of this process before I commit and cut all the parts, because I don't want them all to be cut a little too long or a little too short. So I'm going to get these two stop blocks put in place and then show you this part of the fixture in action. I start by clamping a blank in place with the cut length lines lined up. Next, I place the cut length stop block in place and mark the edge that meets up with the common edge of the bypass block. Then I put a piece of spec tape, double stick tape, over that pencil mark. Now I can align the cut length stop block with alignment marks and stick it down to the spec tape. Then stick the bypass block in place next to it. This sequence holds the blocks firmly, exactly where they need to go, while I drill countersunk pilot holes and drive screws that allow me to remove and replace either or both blocks, depending on what length piece I'm cutting. I start with both blocks in place and cut a couple of pieces to their exact final length. Then I draw a couple of alignment marks between the blocks and remove the stop block to make a first cut on a long piece. Then I quickly replace the stop block to make a length cut on the same piece to show how well this fixture works with this design. So it's back over to the fixture where I cut the miter on one end of some blanks and cut a few more pieces to length because I need guinea pigs for the next step, which is setting up to dado these parts. And for any skeptics in the audience, and I know there are some, this close-up clearly demonstrates how accurate this fixture is at replicating parts of the exact same length. And I think that is pretty tough to argue with. And after taping these two pieces together and sliding them onto the initial drawing, I think I'm going to call that a win. Oh yeah. Well, I hope that everything in the video up to now makes sense. The laying out of the stars, fabrication of star parts, and building and setting up a fixture that can accurately and repetitively produce parts like this for the stars, because all that's important to make sure that at this point you're able to create accurate parts for the stars, which I've done using the fixture as it's built up to this point in the video. And I'm making this little segue here because, as I've said before, at least 3 or 4 times, I'm just doing this whole thing on the fly, and I'll confess that I rather misunderestimated the challenge of dadoing the parts accurately once the parts are made to actually complete a finished star. And what I misunderestimated the most is not building the fixture to cut the parts, but for dialing the fixture in to accurately produce parts with the dados in exactly the right spot for a completed star. And the biggest challenge there is that accuracy gets multiplied by 5. So any error is multiplied by 5 because all the parts have to interlock and fit together nicely. So if the fixture has an error of 1/1000th of an inch or 2/1000ths of an inch, it's going to be 10/1000ths of an inch off by the time it's done. And I might be exaggerating there a bit, but I do know that I had to design the fixture with built-in micro adjustments so that I could dial everything in. But after getting everything set up and making parts of the exact right length and thickness and width, the next step is to set up a dado blade to precisely the same width as the parts and actually just a little bit wider so that the parts don't fit too tight. Now the setup I have here, these parts fit too tight, but I left it that way because I could, and it produces an awesome star. But there's no shame in adding a few extra thousandths of an inch to the dado blade to avoid the fight of fitting really tight dados together while at the same time assembling a star. But as I said, setting up the dado blade to fit the width of pieces you're working with is the next step. Setting up a dado blade is a rabbit hole of its own, so this overview just shows me installing the Forest Dado King 8-inch dado set I use and recommend. To get the 3/4 inch wide slot needed for half-lap joints for the stars, I stack the inner blade, 4 1/8-inch chippers, and a couple of dado blade shims together on the arbor and tighten it up. Then I lower the blade, slip in a width-specific zero clearance insert, and make a quick test cut on a piece of S-crap to check the fit I get. Of course, every dado stack is different, so the mainest thing is that you end up with a slot that gives you a close but loose fit of your star parts. Once I'm okay with the cut width of the dado blade, I put a mark on Star Fixture Enterprise to show how far the fixture needs to travel to cut a half-lap joint. Then I fire up the saw and advance the fixture to cut that slot in the plywood. After dado slotting the fixture, I adjust the depth of cut of the dado stack so it'll cut just a skosh more than half the thickness of the 1/2 inch thick star parts when the time comes to cut a couple hundred precise notches for half-lap joints in 100 or so star parts. And once I had the dado blade set to width and height, I set about adding features and modifying the crosscut sled to cut the slots for half-lap joints in all the star pieces. And in a minute, I'm going to just show this fixture in action for the people that are watching the video for entertainment, and then I'll get into the process of actually modifying the fixture for anybody that might actually be making some stars like this in their shop. But in the meantime, I will just interject an infomercial here to tell you everything I use on this project in this video will be listed on my RecLeague page. And I'm doing that instead of having a bunch of links in the video description to various different sites. There'll be one link to RecLeague. Click that link, head over to RecLeague, and you can find under the current video all the stuff that's used in this video for making these fixtures. And the whole RecLeague thing is a change for me here at Next Level Carpentry, but it's a simpler way to include recommendations to products and services and things I like that I don't have an affiliate relationship with the manufacturer or supplier. Plus the site is searchable, so you can find stuff from this video or any other video. Or if you're just searching for a tool, go to RecLeague and search, and it'll find that tool in whatever video I've used it on here on Next Level Carpentry. And there's also other links, affiliate links for things like this t-shirt on spring. There's a link to the Starbond page for the CA glues I use in this and other videos. So you can find anything you see me using, the stuff that I use, vet, and recommend is there. So the only other link in the video description will be to Patreon for those people that have gone above and beyond to support the channel by becoming patrons. And another perk for being a patron on Patreon for Next Level Carpentry is that all active patrons have access to everything on the RecLeague site, whether that's the subscription stuff or the regular free stuff in front of the paywall. So like I said, it's a change for me. It's still a work in progress, but that's where you'll find recommendations from yours truly and Next Level Carpentry. And with that out of the way, without further delay, I'm going to show you this star part dadoing fixture in action, because after burning brain cells and pushing through, it's pretty cool to see it in action, if I do say. And as with other operations in the video, I've got everything set up for repetitive cuts. And I'm not doing the math right now, but I've got to make at least 200 of these dado cuts in these star parts. And I think it might actually be more, but this is what it looks like. And here's a quick overview of the fixture as it is. As you can see, I removed the stop block and bypass stop block that I used for cutting these pieces to length, and then added an angled fence to hold the pieces at 18 degrees relative to the saw blade. So I take a part that's been cut to length, slide it in here against this micro adjustable stop. Then I use another toggle clamp positioned strategically here to hold the piece tight against the fence and tight into that slot. The bright red lines here and here indicate the path of the dado blade, and this acts as a protective fence. This clamp is just toggled down to keep it out of the way, and it acts as a backup to the screw that holds this stop fence in place. So the way the fixture works is I just take a part, slide it into the stop block, hold it in place with that toggle clamp, then fire up the saw and cut a dado in the bottom of the part. And you can see the stop block extension. I dropped in one of the miter slots to act as a stop once the half-lap dado is cut in the piece. And because the pieces are ambidextrous, once I've cut one dado slot, I simply unclamp the piece, flip it over top for bottom, end for end, reclamp it, and cut a second dado in the opposite end and the opposite face of the piece. And with those two simple operations, I have the half-lap dados cut in one of the pieces, and as you'll see here, they fit a little more snugly than they did when I set up the dado blade, but I decided to leave it like this. But that's what the process looks like for half-lapping these parts. And now I'll cut 8 more of those half-lap dados and 4 more star parts, just to show how nicely the fixture works after the painstaking effort I put into it to get it to work like this. And this shows you the kind of fit I'm getting on these parts, where the fit's actually a bit too snug for practicality, but it does make for an awesome fit on a completed star. And because the pieces are ambidextrous, it doesn't matter which way I put them together. And you can see in the final assembly, there's a little bit of fluctuation in the fit of the star points, and that's where a little looser fit of the dado cut would make life easier if you venture into the star making business. So that's what the front page of the advertisement looks like, but let's get into the fine print. For those of you that want a next level tour down the rabbit hole of next level fixture building. And I'll start by deconstructing this fixture to give you a better understanding of what goes into making a fixture like this for making parts like this. And the mainest thing with this deconstruction is that all the parts of the fixture can be added or subtracted depending on what part of the star making process I'm working on, from cutting sharp points on long pieces to cutting parts to exact length, and switching to a dado blade for putting these half-lap dado notches in the parts. And as you can see, I circle screws that hold components down in green. So I take out only the screws that attach the parts, not screws used for assembly of these components. And the fixture is a lot more user-friendly if everything is set up and indexed, so I can switch into whatever phase of the operation I'm doing at any given time. And with everything stripped away, you can see I'm back at the stage where I've just plowed the dado slot in the fixture. So the first thing I'll mention is this little piece of miter slot stock. Here, I just drop that into the miter slot, bump it up against the initial stop block at the back of the table saw top, and tape it down. And now this miter guide block on the bottom of the fixture bumps into that piece and stops the dado blade right where I want it so I don't keep cutting into the fixture. And as you saw, that piece comes in and out if I need to switch back to the cutting operation with the fixture. Now that you have a pretty good idea of how I cut those notches, I'll show you the process of setting up where those notches get cut. And I have to admit that this is the part that I most misunderestimated, was how precise this location has to be. I started out by just putting one of the parts that's cut to exact length on the geometric drawing here against a straight edge, and then just use the square to show where those notches need to be. And the dado needs to be here on that notch and here on that notch, like this. And this is how I started out, setting up the fixture with marks like this from this drawing, which I figured to be plenty accurate. But I can tell you it's a real challenge. And this is where the combination of error really adds up. This is one of my first attempts. I'm way off on these. I reset up, made a compensation. I got the joints a little closer on this one, but they're all wobbly. And here's another attempt that's pretty darn close, but I never figured it would take that level of precision to get this right, which was a misunderestimation. But that made it clear to me that I had to have a micro adjustment for setting the location of these notches on the fixture. But regardless of where those notches need to go, they still need to be 18 degrees to the edge of the parts. And so while this was still in cutting mode, I took a scrap of plywood, clamped it against that fence, which was set for the precisely 18 degrees, and I ran it past the blade so that I knew my 18-degree block or wedge for this part of the fixture would be the right angle. And this is the picture, or the piece I ended up cutting, this triangle here. And to cut those dados 18 degrees from the edge, I just placed this thing on the edge of my fixture here, and that holds the part at exactly 18 degrees. And this should give you a little more meaningful point of view. I've got this 18-degree wedge, and I ripped a strip of that plywood 1/2 inch and a half wide, just arbitrarily, so that when this piece is on the edge of the fixture and this edge of this block lines up with that piece, I know that this edge right here is 18 degrees to the cut line of the blade. And I just positioned this piece so that it would cut all the way through the workpiece without interfering with the other blocks on the fixture, etc. So this was a little bit random, but it does have a purpose. Once I got this in position, I just screwed this piece and this piece together to hold them. And then I put these two screws in here to hold this piece down. And I have reference marks here drawn on the fixture so that when I take this off and put it back on, it ends up in precisely the same place each and every time. And I learned that when I have clamp pressure on there, which I'll do later, this piece would kind of flex. So I added this little block here to give extra support to this piece under clamping pressure. And a couple of screws hold it in place and provide that extra strength that's needed under clamp pressure. And if you're tracking so far, you can see what I've got going on here. A fence to hold the piece in position. The dado blade has cut this slot just precisely. That's where the edge of the dado is going to be. And this is why it was important to get that dado blade set up for width ahead of time, because this edge right here is critical to getting these half-lap dados cut in the right spot, because I'll take the pencil mark that I just made on the geometric drawing. And that's where I want the piece to land when the dado is cut, so that it puts it right in the right spot. And I mentioned before that the pieces are ambidextrous. So once I get everything set up, I just flip the pieces from one direction to the other. Like this, cuts one slot, and then I flip it over, cuts the other slot. So I don't have to make a left and a right-handed fence for the fixture. I can use one fence for both of those slots once the slots are in the exact right spot. And now, as before, I'll talk about holding this piece in place, and I don't want to have my fingers anywhere near here. It's dangerous to have them that close to the blade, and they're not that good at holding. If this slides 10/1000ths of an inch, the piece is spoiled. So I want to have a positive hold down for the piece, and for that I'll deploy another one of these little toggle clamps. DeStaco makes one just like this, same function, but it's a different function than the clamp I used before over here. This one I push this lever down, this one you pull the lever forward. And I mount it up on the block here because as this thing has clamping action, as this piece comes down, it actually pulls towards the base because this is swinging on a slight arc. You probably can't see it in the video there, but rather than put the clamp here where it can pull the piece away as it tightens up, I put the clamp here so it automatically pulls the piece tight to the fence as it's clamped. And you can see by the target practice I was doing here, this was tricky to get this thing mounted without driving a screw through where it'd get hit by the dado blade, which I've indicated with these bright red hash marks here. But nevertheless, through a process of trial and error, I got the little clamp button where I needed it to be. And one of the challenges is that after the first dado is cut and placed up here, I don't want the clamp pad to end up in that void there. And that was the biggest challenge, is getting it to land on that little triangle island of wood there so it holds the piece down for both of the dados. And like I said, we're off down a rabbit hole, deep in the weeds, whatever you want to say. But discovering all this and acting accordingly is the greater part of the misunderestimation I did for what it was going to take to build this fixture. But now that that's all set up like that, I can theoretically put the piece in here, line up this pencil mark, clamp it down, and make a cut. And because I need to do hundreds of these notches, I need to make a stop for this piece. And as before, I don't want to put a stop on that sharp end. I just want to stop against this face. So let's say that's about where I'm going to end up, and I'll clamp it down there. And then I took another piece that I cut when the fixture was set up for cutting parts, and I made this little wedge that slides in, and this whole surface here contacts, not just one little point. And because I knew I needed micro adjustment, I put a slot in this piece, and rather than making a cam like this, which really wouldn't be the right function, I just made a slot in there, just drilled a series of holes and connected them to get a slot, and then I can drive a screw down through the slot to hold that stop block in place. And it's very repetitive. As long as I don't get sawdust buildup in there, I can just slide this in, clamp it down, and make the cut. And I really hope I'm not going too fast or missing things, so that if you're building a fixture like this, I want you to be able to follow along. And there's just a lot involved. And this right here is the part that I misunderestimated the most, because it took me like 7 tries to get that position dialed in there. And I was really concerned that I might be wasting my effort on this whole video, because if this fails or I couldn't get it dialed in, well, then there's no point in doing a video. So anyways, again, this is the part I misunderestimated the most, because I kept dialing in to get that right. And I burned up a whole bunch of parts, probably 15, 20 or so of my blanks getting it dialed in. And basically, I got it done by trial and error. I learned that I could make 3 pieces, and I don't need to make all 5. If you make 3 pieces and everything fits right, well, then all 5 are going to work. But I started with my initial marks from the drawing, got on here off by a mile, compensated. I thought I was compensating half the difference. You know, whatever this gap is, I thought, okay, I'm compensating half the difference. And then I moved it the wrong direction and made it worse, moved it back the other direction, and it still wasn't right, and did all that dialing in. So I want to prepare viewers with what I'm telling you here. You'll be more prepared for less trials, but make sure you make plenty of sample material so that this part of the build doesn't stop you in your tracks or cause you to bail on it completely. But with all that said, let me go back to the fixture here and show you the simple, straightforward way I addressed this vexing problem. And as I was saying, everything was with trial and error, but I finally got to the point where I knew where I wanted this. I had everything dialed in. I got one piece here, and I'm not sure if you can see this, but this piece overhangs the slot a little bit, and that also lines up with this pencil mark. So that's how much I had to adjust, the difference between that piece and this piece. But let me reset this piece here, the stop block, this, with this lined up. I can just push the stop block up till it hits the piece right there. And I mean, this is just probably 20 thousandths of an inch difference, which is how critical that whole setup is. So lock it down and tighten it up. And then I can make repetitive dados for those half lap joints on these parts. But as you saw, I just disassembled this whole jig and put it back together, and I didn't want to go through all that fussing again to get it set up where the stop block was right. So I took another one of my 18-degree wedges, I slid it in here, and you can see this is off just a little bit, and that much is enough to spoil the parts. So I release this, move this, line these marks on this alignment block for the stop block. All the marks line up. There, 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 there. Then I can tighten this down, lock this down, so I know that everything is set for accurately notching these parts. And I'm pretty sure this is not one of the final parts because it doesn't quite line up on the cut, but everything is set up like it's supposed to be. Here's one of the pieces I made just a little bit ago, and you can see that that lines up. So this is a final cut part, and this one is not. And there's not much difference between the two, but that's all the difference in the world between this working or not. So that's how I ended up back here with this setup for notching these parts. The little bumper lands on there. It doesn't fall off into that dado. Everything is all lined up fine. And also, as before, no fixture is done until it's safe. So I just took another scrap of wood here and slid it in to place just like that and screwed it down. And you can see that the dado kind of plunges into that block a little bit. I've got alignment marks here so I can take it off or put it on at will to serve its purpose as a safety feature. Just like that. And I'm pretty sure anybody that's seen a Next Level Carpentry video before knows that I'm likely to go off into the weeds or go down a rabbit hole. But on this video, I kind of feel like I went off in the weeds just to find a rabbit hole and then went down that rabbit hole to get to this point. So congratulations if you're still sticking with me. And if you're up to it, I'm up to it. I'm going to cut the rest of these parts, get the dados cut in them, and then go off down another rabbit hole for assembling these stars, because there's another little challenge in store for us for that part of the build. After finishing the half-lap dados on these 5 walnut star parts, as your dedicated host and mentor, I spent some time blazing the trail on ahead for the video production by going through the gears to assemble and finish the first of these Christmas star decorations. This is one with cherry and fiddleback maple edging on it. Came out pretty well, but there are a few tips and tricks involved in getting from this stage to this stage. So let me walk you through those as we head towards the end of the video, but I must warn you, there's another rabbit hole ahead. So I'm going to dive into that right now and start the process by sanding these little parts before assembly. It seems that I'm compelled to mention in every Next Level Carpentry video the fact that I hate sanding, and this video is no different. So to make it easy on myself, because nobody's going to do it for me, I put some fresh 320 grit sandpaper on a hand sanding block and sand all 4 faces of each of the 5 star parts before they go to the assembly fixture for glue up. It takes just a minute now, and because the pieces came out of the DW735 thickness planer, they're super smooth, and all this step does is a little bit of touch-up and provide a super smooth surface for the clear finish that goes on the stars after assembly. And I bet you can appreciate the fact, like I do, that this just takes a couple minutes at this stage, but it could easily take a good portion of an hour to sand these parts after assembly and glue up. And with those pieces all sanded to 320 grit, let me give you a close-up of this finished star so you can see where we're headed in the assembly and glue up process. And here's that close-up look. The joinery is 99.9% satisfactory. Most of the points are really nice and tight. A little bit of gappage in a couple of those dados, like this is probably the worst one. But I got a nice smooth finish everywhere. And I really think that the two-tone contrasting wood design was worth the extra effort it takes to achieve it. But now for a moment of truth in putting these 5 pieces together into a star. And this is when all the time spent milling accurate sized parts, cutting them to length, and plowing these half-lap dados all starts to pay off, because any inaccuracy or out of tolerance parts would just be magnified here and keep the star from coming together. But as I've said, these pieces are all ambidextrous, so I can just kind of click them together like this. This is all pretty straightforward, and I'm quite pleased with that. But if you're like me and you've kind of wondered all along, how does this last piece go in here? Well, first off, it's got to be put in the right way. But because of tight tolerances in joinery, that can be a real trick to get that piece in there. And on a softwood star like this one, where the joints don't fit that tight, I can wiggle that piece, that last piece, just kind of wiggle it down in there, and everything works out. And that's because the extra play in the joints and the softer wood make it possible. And I think I could get it done with this walnut and maple star, but as you can see, it's kind of a struggle, and I don't really want to mess up these edges in the process. And if you were making stars out of solid maple with tight fitting joinery, well, you just really can't get that piece in there without messing something else up. So here's the little workaround I came up with for this step, and I can tell you it was a relief figuring this out at this late stage of the game, because not being able to weave the last piece in could be a real deal breaker. And I found that the fit on this star was even tougher than this, and cherry's a bit harder wood than walnut, so there's no way I could get this star put together without this little trick. And all I need to do to effectively get this piece in here like that is simply break the piece in two. Yep, and I can just put this piece in this way, like that, and then lap this piece back in place this way to get all the pieces put together for this star decoration and get that cool woven look effect on the finished star. And so now that you know my little trade secret, I'm going to jump over to the glue up fixture I put together and show you how I do the final fit and glue up of these 6 pieces to a 5-point star. And once again, I guess this is the 3rd time in this video, I'm going to wander off into the weeds to find a rabbit hole to crawl down into and show you details and function of this glue up setup that really streamlines the fit up and glue up process for these stars. And this fixture, like others, starts with a piece of plywood as its foundation. And I think this camera angle will suffice to give you a good view of this setup. And this still shot shows what it takes to get my Osmo Pocket 3 camera in position for a shot like this, where it's suspended from the package arm of the camera boom arm I built in the shop a couple of years ago. And that boom arm has proven to be super practical, user-friendly, and convenient for video production in the Next Level Carpentry shop, to the point that I include a link here to the video I did when I built that boom arm, in case other woodworking content producers want to take their camera positioning and video production to their own next level with a setup like I have in the Next Level Carpentry shop in their shop. But back to the fixture, you can see what I got going on here. A piece of 3/4 inch plywood, and I've got 5 blocks positioned here for the points of the stars. And I put some foil tape on here with a coat of wax on it to prevent any glue from sticking. And I can put the star parts down in here like this, and then position these special little clamping blocks around the star to hold everything in place. And you can see the little gaps in the joinery here, which I can tighten up by applying pressure to these blocks with shims that I can just slip in between a block that's screwed down and then this special clearance block. And the clearance blocks have about a 40-degree included angle here, and then a hole drilled through them for clearance so it doesn't dull the points of the stars. But you can see what this whole setup looks like here. And as I apply pressure to the different blocks going around the star, it tightens all that joinery up. And I can balance it out by shifting the pressure on the different points to get everything closed up and snug like it needs to be. And it also allows me to get this one part that I snapped in half glued back together as part of the process. So that's what the glue up setup's going to look like. But there's a couple preliminary steps that I want to show you here because it's key to making this whole thing work out. So I'm just going to take this star apart again. A nice tight fit on that joint, isn't there? And then I'm just going to line the parts up over here like this, so all the ends are flush and lined up. And the reason I want to do that is so that I can spray some Starbond CA glue accelerator on these surfaces to aid in the glue up steps ahead. So I'll give it a nice generous coat on those angles there, and then on this particular piece I've got a B here for the one of these that's broken, and I'll spray the accelerator on the top piece of this. So the underside of the B has accelerator on it. And now I can just put these pieces in place over here, like so. And remember, these pieces are ambidextrous. So I guess I did that backwards. There we go. Pieces are ambidextrous, so I can always put one face or the other up if there's an A side or a B side to any of these parts. Let's go around here, click these guys in place, like so. And then I'll take the bottom side, the unaccelerated side of this broken piece, and put it just like that. And now I'm just going to roughly position some of these parts here, kind of as a guide for everything, so that I can glue this part back together before the next glue up step. And I want to make sure there's enough play in everything that I can get that part glued together like it needs to be in there. And I must confess, it took a bit of fussing and fiddling to get it to a position where I can get this piece in there right where it needs to be and hold it in place long enough for the CA glue to set. And as you remember, I applied accelerator to this piece here. I'll give it another shot right now and apply some medium thin CA glue to the open broken face of that piece right there. Then slip this little guy down in there, push it and hold it in place for that CA glue to set. And that is all that takes to put one of these stars together in what looks like an impossible fit without that little pro tip for snapping the 5th of 5 star pieces together to complete the outer profile. And with that taken care of, I can proceed with the fit up process here. Again, I'm just using these little blocks and applying pressure with shims. And I can kind of center up this joint in the star with that center line there to make sure everything's getting clamped up with even pressure in the right place. I can really bear down on those shims. And that process opened this joint up just ever so slightly. But I'm going to call that good. Right there, just like that. And now it's time for my next magic trick where I glue up this star where everything's all pre-assembled. And the real magic is made possible because of Starbond CA glue and that accelerator. Because you remember, I sprayed accelerator on all these mating surfaces before putting this all together, so that all I need to do is get some CA glue down in those joints, and that's where the beauty of the water-thin CA glue comes into play. I've got this bottle here, getting kind of empty, but I've got one of the wicking tips on here, and let's see if this is plugged up or not. Looks like it is. So let me get another tip from the handy container that comes with every bottle of Starbond CA glue. Get a half dozen of these micro tips, and I can just snip the end off of that, then slip it over the end of the regular nozzle. And now the CA glue just pours right out of that tip. And I'm going to give a little spray of the accelerator to the face of these so that the excess glue cures. But this is all you need to do to glue these joints. This glue is water thin. It just wicks down into those pores of the wood between the mating pieces. And the accelerator in there cures the CA glue as it seeps in. And I take a couple laps around the star to make sure the gaps in there are completely filled up, which I can tell by the surface of the CA glue, where it pools on the surface once the gap is filled. And once the joints are full to my satisfaction, I give it another spritz of accelerator to quick cure the excess CA glue on all the 5 points. And the nature of the star design, I don't really need to do anything with these internal joints. The star's not going anywhere with these 5 joints sealed up. But if I want to close those gaps, I can just hit them with a little accelerator and then use some of the medium CA glue down in those joints that are a little wider. The water thin just runs in those joints and disappears, but the medium will kind of do some gap filling as it goes in and give me a little better end result when it's all said and done. As the CA glue cures, I can scrape off excess with a sharpened putty knife like this. First by using that sharpened putty knife like a scraper, and then following up using it like a card scraper to remove all the excess glue from the surface of the wood. It takes a few minutes to clean up the joints to my satisfaction, and of course this is a little more difficult because I'm working around a camera suspended over the bench. But the sharpened putty knife is the quickest way I know to clean up the excess glue without the negative effects of using a heavier scraper or endless sanding to remove it. But after several minutes of persistent effort, the glue is removed to my satisfaction, so I switch to 220 grit sandpaper on a Gator sanding block and give the surface of the star a once-over to remove scratches from that sharpened putty knife. And I finish up here by switching to 320 grit sandpaper on a different sanding block for a wonderfully smooth finish that matches the edges I sanded before assembly. And as a final step, I use a puff of compressed air to blow the sanding dust out of pores in the wood so it doesn't spoil the finish later. And with all that done, I pop off the last couple clamps to release the piece and inspect the results, which are more than acceptable, so that I can flip the star over and do a little cleanup and prep work on the joints on the back side of the star. I need to do just a little bit of cleanup of glue that ran through from the front side, and then I follow up with a little water-thin CA to seal up the joints on this face of the star before proceeding to the scraping and sanding steps to finish up. And just to be clear, adding glue to the back face of the star is for purely cosmetic reasons, because the glue applied from the front is more than strong enough to hold this star together for decades. And after completing the sanding steps that I hate, I can blow off extra dust and release the star from the glue-up fixture and switch to the last fabrication step for this star. I almost forgot a small but potentially important detail, so before I do that final fabrication step, I make a detour over to the drill press, where I use a hastily constructed fixture and a small sharp brad point bit to drill a tiny hole through one of the star points that can be used for string or filament in case this decoration ends up hanging from a tree rather than being attached to a wall or placed on a table. Now with that distraction out of the way, I can get to the final fabrication step, which involves using an 1/8" roundover bit and a Bosch Colt router to ease the outer edges of both faces of the star. This step is entirely cosmetic, and I do it because I think it gives the star a warmer look compared to the crisp, sharp corners it currently has. As you can see, the Bosch Colt router is perfect for a step like this because it's compact, ergonomic, and the variable high speed allows me to get a nice, smooth, chip-free cut on the stars. And I decided to get wild and crazy on this star and put that same roundover profile on the inner opening of the star, just because I can, and I'm curious to see how it looks. And you'll notice, because of the nature of the router bit and the guide bearing on it, the roundover profile doesn't continue into the sharp corners on the star, and I want to see sharp, crisp corners where all the edges come together. So I use a small, smooth Nicholson file to continue that roundover profile right into those sharp corners. And by using a rocking motion and confident but careful strokes, it doesn't take long at all to add that sharp, crisp detail to the corners of the stars and remove slight burn marks from the white curly maple accent piece on the stars. After addressing all the burns and corners on the outer perimeter of the star, I switch to the center pentagon and clean those corners up while I'm at it. And of course, I'm not going to leave the job half done, so after completing the face, I flip it over and address the corner detail on the other face of the star while I'm at it. Then after I finish the fastidious filing, I switch to 220 grit sandpaper on a Gator sanding block and give all the rounded corners a once-over. And while I'm at it, I hit the razor-sharp points of the stars to maintain the classification of these as decorations, not weapons. It takes a few minutes to hit all the rounded corners on both faces of the star, but after all the corners get a once-over, I follow up with a light pass with 320 grit sandpaper to make sure everything is smooth, cleaned up, and ready for finish. And I know I already mentioned it, but I'll say it again. I hate sanding, so it's good to have this step finished so I can move on to the funnest part of all, which is making the wood grain come alive with a coat of clear finish. And when I'm done with this tedious task, I give the star a puff of compressed air to clean it up so loose dust doesn't spoil that clear finish. Of course, I could use any number of finishes for these stars, but sometimes simpler is better, so I'm just going with this clear satin 2X Ultra Cover by Rust-Oleum because it's quick, easy, and excellent in my humble opinion. And because of the intricate configuration of the star, I'll apply the clear finish in 2 coats. The first coat is just a light tack coat that I work to get on all faces and edges of the star without missing surfaces or puddling as I spray from all 5 angles of the star. And it's pretty tricky to do, but I use a light touch and a lot of motion to get an even coat on the star. And I absolutely love the way that clear finish makes the deep brown of the walnut and the shimmering chatoyance of the fiddleback maple come alive, even though this is just a first coat. After about 20 minutes under a heat lamp and a fan, that initial tack coat of lacquer is dry, so I give it a quick once-over with 320 grit sandpaper to knock off nibs and to smooth the surface as preparation for a second and final coat of that clear satin lacquer. And even though I really don't care for sanding, it doesn't take long to give the star a once-over, so I can give it a puff of compressed air to clean it up before spraying. And even though this 2-coat process might seem overkill or redundant, it really does make a difference in the quality of the finish on the finished star. And a big part of the reason it makes such a difference is that the second coat has a first coat to cling to when the finish is wet, which minimizes runs, and the first coat acts as a sealer to maximize sheen on the second coat. And I'm trying to demonstrate proper technique while applying this second coat, which involves spraying from every angle necessary and doing all the sides and edges first before checking the sheen in glancing light and applying a couple touch-up spurts of spray to any spots on the face that are still dull after spraying all the edges. And when spraying something like this star, those spots are few and far between. And here's a close-up look at the finished star after that lacquer's had about a half an hour to dry. You can see the sheen on all the surfaces, front and back, nice and smooth, tight joinery. I love that walnut wood grain, and it just glows with that finish on it. And now, at long last, after that journey off into the weeds and in and out of rabbit holes, the finish is completely dry. And I can say, as always, and until next time, thanks for watching. Well, hey, I gotta say, it's good to see at least a few of you here at the end of this video and very near the end of the year 2025. I was hoping to get this star decoration video done much sooner, but life gets complicated, so production and release of the video got delayed by a couple of weeks. So even the most ambitious folks out there wouldn't be able to make stars like this for this Christmas, but hey, there's always next year. And at that, I hope that this was at least entertaining to see what's involved in making a couple of stars that I thought were going to be somewhat simpler than they were. But I'm super pleased with the results. I hope you like what you see there and that you enjoyed the video. So from me and from Chip, from the Next Level Carpentry Shop, Merry Christmas 2025, and I look forward to seeing you at the end of a video at the beginning of 2026 after you have a happy new year. See ya.